Welcome to Make Me Data Literate, the podcast that makes data intelligible from the Australian Data Science Education Institute. We're on a mission to make the whole world data literate. I'm your host, Dr. Linda McIver, and every week I'll interview someone with a wild and wonderful relationship to data. Let's see what we can find out. Hello, and thank you for joining us for another episode of Make Me Data Literate. I'm very excited about this episode because we have Antony Green joining us. I'm going to get into some election data. Thank you for coming, Antony.
Thank you.
So I'm going to start with my usual question. Who are you and what do you do?
My name's Antony Green. I'm employed by the ABC as a Chief Election Analyst. I'm responsible for the ABC website, the background material, responsible for the setup of the ABC computer, the fine-tuning of the predictive tools, the preparation of the data. It's a time-consuming process, and essentially the accuracy of election night depends on your preparation. And if you have good setup data and everything's set up beforehand, then you'll have a good election night, which for me is being accurate.
That's the challenge, isn't it? With the way the data, the speed that the data changes with must be an insane challenge for you.
Yeah, it's one of the questions you sent me was what do you find interesting about this sort of work, and it's basically that on election night we are sent an XML file with a whole bunch of data, and you've got to make sense of what it means. So while everyone's watching a graph on camera or something, there's a whole bunch of maths and data analysis going on underneath to turn a file into something that is meaningful in terms of political analysis. So it's an interesting exercise, and the work on it on election starts months before the election in terms of the preparation. So it's not something you just turn up in the night and talk about.
I can't even begin to imagine how complex the preparation must be. What does it involve?
Well, it varies. At the federal election, we get a lot more of the historical data from the Electoral Commission, which helps. But at the state level, you've got things like redistributions you have to calculate. You have to get the results of the last election, get them into a format. You have to manually prepare the historical data and then make sure it can match up with the polling places that come from the Electoral Commission, make sure you get the information on the polling places, that you can resolve differences in polling places from one election to the next, reallocate votes or split a polling place. So there's a lot of that sort of very tedious preparation. And you do as much of it as you can well ahead, but in the end, some of it just can't get done until the campaign itself.
So a lot of your predictions are based on.
Yeah, the biggest correlate of an election result is the result last time. If you want to know when the figures are coming in, polling places are not random. They have underlying general voting trends. And
Yeah.
from election to election, polling places tend to reflect the result of the last election. It's just, and then on election night, um, you've got two ways of looking at the data. One is to look at the votes as they come in. And as the votes come in, they have statistical bias and they have statistical variance. The bias in Australia is caused by the fact that smaller polling places report first because they're easy to count, and smaller polling places tend to be rural booths. They tend to be anti-Labor booths. So the statistical bias in early figures is that the Labor Party vote starts low and rises through the night. But the method we tend to use in Australia is what's called matched polling places. We look at the swing from polling place to polling place rather than actually the raw vote. And the polling place, the swing is not correlated with booth size generally, where vote is. Swing, change in vote isn't. And change in vote from polling place to polling place also has a smaller variance than the two-party preferred result from polling place to polling place. So if you operate on the swing, you minimize the bias and have a smaller variance to deal with and have a more reliable predictor. At all times on election night, your figures are predictors of the final outcome. So if you can eliminate bias and variance, you have a better predictor.
That's so interesting. Man, I could go into this all day. But I'm aware I don't want to monopolize your time. So we'll get back to the questions. Did you, was your formal education sufficient to do this work, or did you have to do a lot of sort of self-education in order to?
I happen to have the right qualifications. I mean, I did a science maths degree after school. I worked in the computer industry for several years. I went back to university, did an economics politics degree. Um, in that economics, I did more of my statistics. I don't have a formal statistics qualification, but I have like 2 years of economic statistics as a background. So, and particularly years later, I couldn't go back and do sort of a lot of formal statistics. But to be honest, for a lot of what I do, which is more day-to-day stuff, I'm doing much more descriptive statistics. I mean, we used to do some regression analysis and stuff. We don't even do that anymore. I'm mainly working in the area of descriptive statistics. Don't get much beyond variance, bias, and medians and means. So I don't have a formal qualification in statistics, but the main thing I was hired in 1989. And in those days, trying to find someone with computer skills was pretty rare. And I had several years working in the computer industry as a programmer, and data analyst. So I knew how to do databases, program basic stuff. Now, I must admit, my programming skills are a bit out of date these days. Data comes in a lot more formats than it used to. There's a lot of languages designed around data formats like XML and JSON and stuff. And I must admit, my skills in languages which deal with those sorts of formats aren't great. And a bit of self-training has got to come in there. But the fact that I had the background in computing was a huge advantage for a lot of journalists who were doing election coverage and didn't know how to talk to the engineers who used to write computer programs in those days.
And so, just for the tech nerds among us, what software, what languages do you use for your
Actually,
software?
I don't know what the language is now. It's just been rewritten 2 years ago, and it's not a language I particularly know the name of, to be honest. It's just one of the modern languages. I think they're using MuleSoft as some sort of interface because everything now is tied to an internet. But, when we designed the first computer system, it was just for a television election coverage. Nowadays, we're publishing to a website. There's the World Wide Web. So there's this vast interface built around the computer system nowadays to deal with a load of inquiries from the internet. I know, there's a few people in the blogging community do election results sites, but the volume of hits on the ABC site compared to people doing those sorts of sites is vast. I mean, at most state elections, we get more hits than the Electoral Commission. And the federal elections roughly on the par with the Electoral Commission.
Oh wow!
So our computer systems have to cope with that load. So there's all this intermediary software which deals with requests and sieves requests down. So that's all way beyond me nowadays. I just look after making sure the data is accurate. I didn't design the mathematics. Mathematics was designed by Dr. Ross Cunningham, who was a CSIRO later at ANU. I think he's still an emeritus professor there nowadays. I haven't spoken to him for many years, but he did his master's or PhD, I can't remember, on election prediction, and still did the seminal papers. Did the seminal papers on that 40 years ago. And to be honest, there's not much improvement apart from perhaps doing a regression model. Would be the only advancement to get an earlier prediction. But one of the difficulties with a regression model is that the biggest correlative swing in Australia is state. And if you've got different time zones, you don't know what the state swing is until the time zone closes. So you might apply the swing from a safe Liberal seat in Sydney to a safe Liberal seat in Brisbane, and then find that the general swing in Queensland is quite different. So the actual fact that you're comparing two like electorates in terms of partisanship is actually irrelevant because the bigger difference would be state. So I think you can do good regression models. We used to use one, but we had problems with it for years. And in the end, I suspect regression just brings you in. It doesn't just makes you call it a little bit early. It doesn't make a huge difference. The biggest difference is just being able to use swing.
That makes sense. Is there anything that you wish everyone knew about data?
Yes, that if people had understood that the average is only one way of measuring data, something about data. It's only one descriptive statistic of an election. The classic always comes up to me in my occupation is people talk about an average swing. And I think an average swing is nearly a useless figure to use for a by-election because the variance is enormous. Because the things that cause the swing vary from by-election to a by-election. So we had a by-election in Monero a couple of years ago. It's unusual for there to be a by-election in a marginal opposition seat. It's normally most by-elections we deal with tend to be in government seats, and we talk about a
Yep.
swing against the government. So people would talk about the average swing. A more relevant figure was an average swing in an opposition-held seat, and that was quite a different figure. But even then, at the time, the by-election was held in the middle of COVID, so you were trying to compare statistics at a time when the government was popular in the middle of a pandemic, and there aren't many examples of that. So that's the one thing I tend to know is people automatically use an average, and you say to people, well, if you're using an average, some statistics you should use the median. House prices are a good example. You should use the median, not the average. And in some things, the average is a meaningless description. As I always remind people, the average of 49 and 51 is the same as the average of 1 and 99. But the two distributions have completely different variances. So you've got to look at the first three generating functions of a statistical function. I think they're the average, the variance, and the skewness. I mean, they're the three things you need to know about a statistical distribution that's underlying what you're talking about. And I'll say the other thing is also a tendency for people to use change as as the variable you want to talk about rather than the actual value. So things like inflation. The inflation is a good measure of something rather, but talking about the change of inflation from the previous period it's a derivative integral. I can't remember my maths now. It's a change. It's a different measure, and I find that people do odd percentages of change, or people compare two numbers and calculate there's been a 50% increase in this number, and sometimes that's just an unreliable way to look at data. I always look at that sort of data thing. When someone says to me, "Oh," or sometimes it's the data itself. You need to know something about the data to make sense of the statistics. There were some figures released last week in Sydney which showed that the usage of the new light rail had doubled in the last year. And this was seen as a positive thing. Now, yes, sure, it was, and it is positive, and it certainly has improved its service, and more people are using it. But there are two big things. Last year we were coming out of COVID, and a lot of people were still working from home. And the other thing was we now have overseas students again, and they're all going to New South Wales University or coming into the city. So there's a couple of things about the data, which means that increase is not so surprising. So I always find that interaction of data and the descriptive statistics that come from the data. You always have to go back and look at the data. I'll talk about ecological fallacy a little bit at various times. That's always one where you apply the attributes of a group to the individuals. In my area, is always one of the great, mistakes that people make.
Yes.
And the classic for me was at the last election, Labor did much better in a series, and the Teals did very well in a series of affluent Liberal electorates. And people were saying, and the National Party continued to hold a lot of quite poor electorates measured on income. That ignores other attributes of those electorates. But you can't say because Labor won a series of affluent electorates that rich people are now voting Labor. That's just not correct. That's the wrong way. You cannot draw that conclusion. Income is not the overwhelming characteristic in that way. So that's always one that gets me in my area.
That always frustrates me when we teach statistics and data. We often teach them in isolation from the context. So, the maths curriculum says things like for linear data, you use a line graph, and for discrete data, you use a bar chart. And it completely ignores the context and what you're trying to say. And, I don't think you can work with data and just apply formulae without understanding the context of the data and knowing,
you also get
the surrounding
different
influences.
areas of study use statistics differently. If you're working in physics, your statistics are clear cut. You get very strong relationships in physics because the laws of physics work that. When you're in social statistics, you do not get that. You have to do a different sort of statistics. And having done economic statistics, you have something called heteroscedasticity. The data isn't homoscedastic, which is an attribute which most people don't worry about in other fields, but matters in economics because your x-axis is more often than not time. And over time, what you're measuring changes. And the classic is that the variance is greater as you graph data. Over time, the variance of whatever you're measuring may grow compared to when you started measuring 10 years ago. And therefore, when you do linear regressions on that data, you get an invalid current. The change in the variance affects your linear regression and gives you a false relationship. So you always have to be aware of that in economic statistics, but you don't see it in many other fields. And I remember doing a blog post which was comparing green vote to education levels or to Labour vote, and I graphed it, and I could see the data's not it's got heteroscedasticity at the strong Labour vote end. The variance is greater than at the low Labour vote end. So when I draw this regression line, I'm seeing something else. It's usually a sign that you've got another variable you should look at if you're doing it in social statistics. And in that case, the causative variable was education level, not Labour vote. And that's the big correlate of green voting, not Labour votes. It's just
right.
There's always those sorts of things that come up. In my area, there's a concept called uniform swing. If you get a national swing of 4%, most seats under 4% will tend to fall. Now, it's not determinative. The national swing is made up of 151 individual swings in electorates. It's a total of the swings in all the electorates, the history and things.
Yeah.
But the swings are clustered around the national average. There are seats which are of a bigger swing and seats which have a smaller swing. And on average, you come up with a national swing. And a classic I always hear from journalists who say the swing wasn't uniform. What they mean by that is it wasn't all in the same direction. Now, of course, it's not all in the same direction. It's because it's clustered around the average. And if the average is zero, for instance, half of them will be positive and half of them will be negative, roughly, on average. So if you can have a swing which is 5% in one direction and is not uniform because the variance is very large, and you can have a swing with zero, with a low variance, and the swings can be in both directions because the average is zero. And people think that's what you mean by not a uniform swing. Uniform swing must be measured by variance, not by positive or negative signs. So that's a classic one I get. It's not a. It's just people don't understand that a national figure is an average of lots of underlying figures, and that's just what I always find. People don't think of functions; they think of a straight line, or they think of a particular number. That number is often just a descriptive statistic of an underlying distribution.
It's a bit like when you see headlines screaming that 50% of people are below average at something. It's like, well, yes. What are the worst data mistakes you've seen?
In my area, it's applying, in economics, what's the phrase, ceteris paribus, assuming everything else is the same. Economists got a great effort to do one model analysis of economics of something. They try and find something where they're pretty sure everything else is random and see whether this one value gives you a meaningful statistic. And more often than not, the bad cases of this I see in relation to election statistics is the application of a single variable to electorate level data, and it falls into ecological fallacy. And that's ecological fallacy is almost always caused by the fact that variables are complex. I saw one many years ago which looked at the size of the swing against the Gillard government based on the number of people who were on the single mother's pension because the government had cut the rating. And they came up with a positive correlation. Well, the number of people in each electorate which have got a single mother's pension is quite small. It might only be 2, 3, 4%. It's a small number. And if you regress across a whole election, it's going to be heavily weighted by the small number of electorates which have got numbers and things like that. I remember someone wanted to do some analysis based on the proportion of the electorate which were Jewish and looking at swing. I said, but there's only about 5 electorates in the country which have got a meaningful proportion of Jewish voters. So, you can't do it because the data is just not there. It just doesn't mean anything. If you look at income's related usually also to wealth, and it's got some relation to voting intention. A joke I heard about the most recent election with the election of the Teal candidates was that 20 years ago, they used to talk about doctors' wives, the voting patterns of doctors' wives. Nowadays, those wives are the doctors. It seems.
Yeah.
So yeah, I just voting patterns are complex, and the more you look at the survey data, you see how
Yeah.
complex it is. When you look at the maps of, I mean, I'm quite interested to look at maps of census statistics versus voting patterns. It is interesting. You do see a lot. You do learn a lot. But I somewhere in my office he'll still have an atlas of Sydney done from the 1976 census by Peter Sparrett and someone Paulson. One was a statistician, one was a political scientist. Very basic plotting in those days. But on each graph, they had a discussion about, you had these plastic overlays of state and federal boundaries. So you could look at the electorates, the plot of Sydney with these maps over the top. It's much more sophisticated these days. But what was really sophisticated on that was that a page of
Yep.
description of the statistics and the relationship to voting patterns and stuff. And every page suggested another page in the book where there was a related variable. And that was what to me was so important, was that it teaches you that
Yep.
simple thing of saying this is related to that as another variable. And so everything in the social sciences, you do not get the 90% correlations you do in physics. You're lucky to get, yeah, you're lucky to get with
No.
a correlation regression of 0.3, and you can say, this has got a 95% confidence interval. But someone in physics would look at those statistics and say, "You're joking. That's not a relationship." No. I'm always mindful of Rutherford, the physicist in the early part of the 20th century. His gold leaf experiment, except science, the gold leaf experiments where they fired, I think it was electrons or neutrons at this gold leaf, and they had measurements around, and not a lot of them, most of them sprayed all over the place, but every so often one would bounce straight back. And this proved that the atom was very small compared to the overall thing. So there's a clear relationship involved in that. But you just don't get that in social sciences and economics. And sometimes it strikes me we give far too much credibility to very, very simple economic models. Someone proves one variable is important. Well, it's only one variable of many.
Yeah. Well, there's a temptation, isn't there, to try to reduce complex social issues to a single factor. We like clear things. We like bold statements, and if you can pull it down to one thing, it just makes it sort of manageable.
And then you get to
but
the
not
area of,
necessarily real.
you get views about the cause of something, but you actually have no data on it. So, for instance, people say such and such is caused by bad parenting, and you say, well, what's your measure of bad parenting? There isn't one.
Yeah.
So people use something else like broken families, or So you get these. They use those sorts of statistics, and those sorts of statistics end up completely ignoring bad parenting in families that don't break down, or child abuse in families that it doesn't come to the attention because it's within family rather than outside of family. You get those sorts of things, which they just don't get measured. It's always when I was studying politics, I read a book which I was very, very always recommend to people by a paleontologist called Stephen Jay Gould, who was an evolutionary theorist. He wrote a book called The Mismeasure of Man. And what that was about was the origin of a lot of statistics by people like Galton and Spearman, names which we use in statistics. Most of what they were doing over 100 years ago was trying to find measures of intelligence. And what this book revealed was that all the early statisticians, who were actually people who were doing theory, they were trying to find ways to measure social stuff. The British were always obsessed about class. And so all their measurements seemed to be about class. The Americans were always obsessed by race. And we do that. And there was a chapter very early in the book, and it was about experiments done by Germans and French trying to measure the size of brains. They presumed bigger brains meant people were more intelligent. It was Paul Broca and Gauss. And they both came up independently with this idea of getting a selection of skulls, filling them with ball bearings to measure the volume and coming up with it. And of course, they compared different nations, And I think Brockle was the Frenchman, and he proved that the French had bigger brains than the Germans. And independently, the German Gauss proved that the Germans had bigger brains than the French. And you go through a lot of these early statistics, and admittedly these days, most proper statisticians, social scientists, and economists are aware of those biases, um, the measure biases.
Yep.
The bias is in the eye of the beholder, and they don't realize
Mm-hmm.
it. But so many of those early figures who were doing the proof of who's smarter than others were based on all sorts of strange measurements. And also, sometimes, it's like the original development of the IQ tests was about measuring people who were well away from the average. It wasn't about trying to measure that people had an IQ 10 points higher than somebody else. They were trying to measure people who were 2 standard deviations away from the average. They were trying to work out who needed more work.
Mm-hmm.
They weren't trying to come up with a continuous measure. So that book's always influenced me. That people walk in thinking they're measuring something and don't understand the biases in their own testing procedure. Now it's a standard thing now. Yeah.
It's immensely difficult to interrogate your own bias, isn't it? You can't see it because it's built in. It's interesting too, some of the measures that have sort of snuck through from that time, like the BMI, the body mass index, which is completely it's not applicable to an individual. It was always intended to be a population measure, and it was not really a measure of anything. It was just it was an idea come up with by a statistician, and it wasn't really it's being wildly misused now. There was no medical basis.
I think there's lots of examples of that, but people always want to find something to measure. They can see a phenomenon, they want to come up with a measure for it. But I always say, a good example of you don't actually, a measure doesn't have to have any meaning, is to look at people who chart the stock exchange. What you're doing in that is you're trying to measure the behavior revealed by the indexes. And if you do lots of analysis, you can work out that people are more likely to sell after lunch, or things like that. There's lots of things you can do, and you can bet against the trend.
Yep.
So that's, if you can find something which correlates with something you're interested in, like share price. If you've got something else which correlates very strongly with it, even though they have no relationship or no real relationship, they correlate with each other, and you can use it as a measure of something else. So you get examples like that. People say to me, such and such a polling place in an individual electorate always goes with the trend. So I'll wait for that polling place and I'll call the seat on that. That's fine, except the problem is you might have a third of the polling places in by the time that one arrives. I know a New Zealand election that used to use these indicator booths. It's what's called an indicator booth method. You don't use all polling places, you use specific ones. But they did a New Zealand election in 1990, which was a landslide. And by the time the indicator booths came in, the result was clear anyway. So sometimes there are different methods that you can use. And everyone's got a method of trying to work out what's going on in society, or what's the way to, particularly someone who's investing. You want an investment strategy, you want to find some way to measure something. In my area, this comes up in something called strategic voting, where people, if I vote for, in Britain where they have first past the post, and explain this as a simple model, you might have 3 candidates, a Conservative, a Liberal Democrat, and a Labor candidate. And it's first past the voting, so you've only got 1 vote. What's your strategy for voting? The sensible strategy is always to vote for the candidate you want to win. But if you've only got 1 vote, there's no preferences. If you're voting for Labor, and there's a Liberal Democrat in the field, and then voting for Labor, you stop the Liberal Democrat defeating the Conservative, and your real interest is making sure the Conservative doesn't win. Then there's an alternative strategy, which is to vote for the candidate most likely to defeat the Conservative. That's called strategic voting. You are changing, instead of revealing your preference, you are voting in such a way you're betting against how everybody else is elected is voting to achieve a certain strategy. And so you get people in this country talk about strategic voting. It's much harder to do here because we have preferential voting. So you can vote for a third party without you can vote for the Greens without hurting Labor's chance of winning a seat. But what we're increasingly seeing with the decline of the major party vote, you're getting situations where you've got Labor and the Green competing for second place, so or an independent. So strategic voting on preferences might have an impact. The British political scientists who criticise preferential voting always say it's wide open for manipulation, because you can say, I'm a candidate on 40% of the vote. If I lower my vote by getting people to support me to go and vote for somebody else, then I can increase my chances of getting elected by lowering my vote, by giving up some of my voters to split others. There is evidence of this in things like voting for Olympic cities, where you've got 5 competing. When London won the Olympics in 2012, there were 5 cities originally going for that bid, and they vote in rounds where after every round someone drops out. When you look at the votes, there were clearly examples in that rounds of voting of London getting some of their supporters to vote for somebody else to knock out a real competitor in an early round. So that's what strategic voting. So people get obsessed about strategic voting in this country. But I always say to people, preferential voting has the assumption underneath it that you will vote, that voters vote for the candidates they want elected in the order they appear on the ballot paper. And that's the whole basis of the counting method. Yeah. The assumption is these ballot papers are in preferred candidate order. And so that's why they count that way, count the way we do. We drop out the lower polling ones. If you vote strategically and you get your ordering wrong, you can't guarantee your vote will be for your preferred candidates. Your vote, because you voted strategically in another way, you can't guarantee your vote doesn't end up with somebody else, rather than your preferred final. A good example, in 2004, at the federal election, under our now abolished group voting ticket system where the parties control preferences, the Labor Party did a preference deal with a number of minor parties, including Family First, to try and increase Labor's chance of its third candidate defeating the Greens. So because they could control their preferences under the group voting ticket system, everybody who voted the Labor ticket went by that. They traded off their ability to determine a binary choice between Family First and the Greens. They traded off that. If it came down to only 2 candidates, what was their preferred option? They traded off that for the ability of assuming Family First wouldn't get into the final 2, and therefore they'd benefit for their preferences. So they traded off their ability to determine who won the final seat for increasing their chances of their third candidate winning the final seat. So that was strategic preferencing, and it failed because the assumptions didn't work out that way. This is a strange statistical game. Now, in preferential voting in the real world, where we've got 100,000 voters in the electorate, the silly little examples like 100 delegates voting for a city to host the Olympics, where everybody knows the other 100 voters. When you got 100,000 voters, you haven't got a chance. There are cases in our country of very close preferential races where second and third are very close, and the order of who finished second will determine who defeats the leading candidate. There's a case in Sydney in 1981, the seat of North Shore. An independent, Ted Mack, was neck and neck with Labor for second place. And if Ted Mack got into second place, the Labor preferences would elect him over the Liberal. And so the Labor Party screwed, whereas if it was the other way and Labor was second, Labor wouldn't win because preferences would exhaust. Labor scrutineers went in there to knock out as many Labor votes as possible. They wanted to knock Labor votes out so they fell to third. So that's an example of strategic voting at the scrutineering stage. But the chances of an individual voter having any effect in a situation like that doesn't matter, because you don't know the order you will finish. I know people who try to ensure that their vote goes through every candidate before reaching one of the final 2. So they try and guess the order of the candidates in increasing voting. So they vote for the lowest and then the second and the third. That's a nice strategy, but if you get it wrong, your vote's going to go to somebody else you didn't intend to along the way. And if you get it completely wrong, you could end up going to a candidate you didn't want to elect, especially in the Senate. So anyway, so I think this is more in the area of game theory than statistics, I think. So that's that's what I just want to say about
Yes.
this concept of strategic voting. Underlying the concept of a strategic vote is you are voting in a manner which is based on how everyone else is voting. It's not based on what you want your vote to do. So that's
Yes.
the point that I always make to people who advocate strategic voting. Strategic voting is useless if everybody strategically votes, because nobody can guess how everybody else is voting then.
Yeah. Yep. It's also, if you look at the polling before elections and the predictions of who's going to win various elections, we know that predicting other people's votes is
Which
a dicey
it
game.
comes down to individual seats. The case of the Wentworth by-election in 2018, there was a Liberal candidate who was going to lead on first preferences. There was the independent Karen Phelps, there's a Labor candidate, a Green candidate, and sundry others. The Greens issued a how-to-vote card which put Labor ahead of Karen Phelps. And there was great angst that if Green voters followed that how-to-vote, it would put Labor ahead of Karen Phelps and stop Karen Phelps getting to second place. In the end, it didn't matter because she finished second. People abandoned the Labor Party to vote for her. There was some strategic shift of first preferences to engineer an outcome. We saw that with all the Teal seats at the federal election. All of the independent Teals finished third. They got ahead. They finished second. Basically, a lot of Green voters and Labor voters didn't vote for their preferred party. They voted for the Teal candidate with the aim of maximising the chance of defeating the Liberal. It's one of those rare cases where you can see evidence of strategic voting. But as I always say, if you're not sure the order that candidates will finish, strategic voting doesn't necessarily work as a strategy, but it did work very importantly in the last federal election.
There was one point in the last federal election during the coverage when you were knocking out various results from various seats because your system, there was something unusual about the data that meant your system wasn't handling it. And you said, I remember very clearly, you said, my brain is burning.
It was basically all those seats where there are independents running. We operate on a system which compares two candidate preferred vote by polling place. So we get an accurate two candidate preferred swing polling place by polling place. Once you've got a sample of polling places, it's a good predictor of the final outcome. You apply the uniform swing to the results of the district in the last election, and that's your predictor. And that predictor is unbiased and has a small variance. So that's the way we work. In those Teal seats, we didn't have a two candidate preferred from last time. And our two party preferred measures Labourness versus Liberalness. It measures in every polling place, it gives you a measure of how Labor leaning an area is or how coalition leaning is an area, and those patterns are stable. When you toss in an independent, for a start, you don't have a historical two candidate preferred basis. And the variance of the two party preferred from polling place to polling place is an underlying is actually created by the variance of the first preference vote for the Labor and the Liberal Party. There are minor parties, but their variance from polling place to polling place isn't normally important. In fact, the variance of the two party preferred vote is a measure of the variance of the primary major party vote. When you throw in an independent, a Teal independent, what's the pattern of their support against the district versus the Liberal Party? So your two-party preferred was a measure of Labourness versus Liberalness. And it isn't anymore because you're using an independent who may draw their support in different proportions across the electorate. So the swing variable is suddenly not as reliable. The variance will be larger because you're measuring your final two candidates different. So what we had to do in those electorates, we put a hold on them. We didn't let it use the preference count because we didn't think it was a reliable predictor. But we were operating off the first preference vote of the Liberal Party. We had a measure of the Liberal first preference vote to the last election, and it was reliable, we were of the view. But we couldn't use the two candidate preferred because it was unreliable. And so therefore I had to make the manual decision. And I was thinking, at what point am I confident this first preference prediction, because we predict on a swing on first preference, can that gap, is that predictor good enough and we're sure that nobody's going to get passed on preferences? So we were doing that sort of modelling and it had to be done more manually. And so that was the difficulty. So we, at the last federal election, we had a clear it was clear that coalition was losing, though I must admit I was focusing more on whether Labor was going to reach the majority, and I was watching that figure more. I also should have spent more time looking at the coalition was doing badly. The coalition was doing badly because they were losing seats to Labor and because of these teals. But then I couldn't call the teal seats because we had unreliable data. So we had suddenly had this three-way picture going on rather than the traditional two-way picture we do our modelling. So it meant I had to make more personal decisions. And we had to go and look at the individual seat. The recent New South Wales election, we over-predicted the number of seats won by Labor. I've been and looked at the data, and there was an increase in the post and the pre-poll vote, which meant there were a bigger sample of the overall vote. And we didn't get all of those on the night. And as we know, after the election, the swing away from Labor amongst pre-polls and postals was much larger than at the previous election. Our model had factored in that the Labor vote after election night would drop 0.5%, which is what it was in 2019. In fact, in a number of elections, it reached 2%. So a seat which was 52% on the night, which we would normally call, in fact, the seat of Ryde was an example. If they're on 52 on the night, Labor would normally win that seat, but they lost it because the swing in the post-election, in the pre-election figures, votes counted, which we didn't have all over the night, was substantially different. Now, you don't know that beforehand. As I said, we'd factored in the trend from last time. The trend was different. The difference between on the day and pre-election was different than last time. So we'll build in a bigger fudge factor next time. If you don't know what the trend in the data to come is, the only way you can deal with it is give your predictor a bigger variance. You put a function in which makes your variance wider, which means it lowers your probability of a prediction. So I've completely rerun that election and played around with our factors on the formula, and that's basically, if I'd used a slightly different factor, then I wouldn't have got Labor above 47. I still would have had them more than the 45 they won, but I wouldn't have been over-predicting as much. So if you get the result doesn't seem to match what you thought it was going to be on the night, you go and look at your model and figure out where it was wrong. And in this case, there was different behaviour in the post-election booths. And what I was saying earlier about why we use swing rather than votes, I said that swing traditionally isn't correlated with booth size. Now, what's happening now is we are getting large lumps of pre-poll votes coming in. So these are like 4, 5, 6,000. They are way bigger than a polling place. And these pre-polls are coming in, and their swing is different. So suddenly we've got a correlation between booth size and swing, which we didn't used to have. And we don't know yet. We don't know that correlation is going to be there until those figures turn up, because the pre-polls, because they're larger, come in last. So if we don't know whether there is or is not going to be a different trend in those pre-polls, all you can do is just tone down the prediction, tone down your probability function and your variance function to allow more variability on the votes to come. So the assumption we've used that swing is not correlated with booth size has been breached in the last 5 years, because pre-polls are larger, and sometimes, that means sometimes, not all the time, they are sometimes significantly different than on the day vote.
Do you feel like the data, the sort of historical data, is less reliable?
It's unreliable for two reasons. One is that we're getting more seats that are two-party preferred, so that the third-party vote's more important. And that third-party vote, particularly say for the Greens, does vary across a polling place, across an election. Once upon a time, we would assume the third-party vote had a very small variance, very small bias in the polling places. That's not the case for the Greens. It's also not the case for One Nation. So we've got two minor parties that have their own distribution function across the polling places. And that is factoring into the two-party preferred, where normally we only had to worry about this one-dimensional function, which is Labourness versus Liberalness. Well, now we've got two smaller parties that have their own distribution, and that is factoring into the preference flows in the two-party preferred. So it is becoming unreliable because it's not quite as two-dimensional as it used to be, or one-dimensional as it used to be. So it's no longer a bivariate Liberal versus coalition. we've actually got some other functions going on in the background. And with preferential voting, as we saw in seats like McNamara and Brisbane at the last election, it's the order of candidates which determines who wins. So suddenly, the statistics which you always applied at preference levels, we're now having to play around with them at the primary vote level to determine an order of candidates before we go on to the next. Now, in fact, we haven't modified to use fancy statistical decision making on primary votes. It's just too wildly complex at this stage. But it does mean we put more variability to those seats and pay more attention to the predicted primary vote. If I got a real statistician, I was going to say, if I got a real statistician in to look at this, they'd be doing all sorts of fancy artificial intelligence stuff and stuff. But in the end, they can only do it if we had the data for them. I mean, in the end, you spend so much time preparing the data, coming up with fancy artificial intelligence to deal with it. It's not something you get to do very often in an election. And what you don't know is you analyze one election, you don't know whether that's just a function of this election or another election, or is it more general? And in the end, actually, a good example, actually, just on probability statistics. In our seat, we don't give away a seat until our probability function reaches 99%. We use a very high level of probability, and everyone in statistics uses 95 or 99%. In the 2016 American election, the 538.com site was using opinion polls at the state level to predict an outcome. And they came up with a probability, I think Hillary Clinton was 72% likely to win the election. Now, for a statistician, that's just not enough. You need more better certainty than 72%. If you're gambling, 72% is good because you're betting a binary outcome. If it's 72% likely, I'll just keep betting on this one. And if it's repeatable, I will win. But a presidential election is not a repeatable event. So you can't use a 72% probability. You need something which is more robust. So, and I find people, I keep getting this argument, let's plot the probability. Actually, one of the worst things with probabilities is people turn them into percentages. I say probability should always be done as a decimal, 0.72, not 72%. Because people confuse that with a vote. I get people when they want to plot probability curves. When can we plot the probability of this seat being decided on the night? I said no, because probability functions, they run along at 0. You get to about 46%. Now, there's a great sine wave up to 0 to 1 at 54%. So all the movement in a probability function is clustered around the average. It's clustered around the point where you're measuring. On election night, you're measuring whether a current two-candidate preferred is greater or less than 50%. You build a confidence interval. You normalize the variable, produce a confidence interval. You're measuring the 99% point where the confidence interval is greater than 50. But if you plot the probability curve, all the movement is in the middle of the function. But people, when you quote a percentage, presume it's a straight line, and it's not. Probability function is not a straight line function, and people, I think, constantly mistake, use probability. People say there's an 80% chance of Labor winning the election. Well, yeah, but that's a betting odds. You're using it like betting odds, and this is not a repeatable event. So 80% is not good enough.
Yeah, I think there's definitely a complete misunderstanding of that.
I think people understand straight line functions in life. That's why you see so many people use linear regression. People like, but to have a quadratic function or a sine function or a probability function, these are all different. A binary function. They're different forms of underlying distributions, and the human brain does not work statistically. I mean, it does deep inside. The human brain does categorize based on history, so it does do some sort of analysis of I can trust this person, I can't trust that person. But really, when you start to throw numbers around, everyone works linearly. You ask people to draw 100 random dots on a chart, and a human will always draw something with a pattern because they can't really do random.
That's why people had so much trouble with COVID initially, because they didn't understand the idea of an exponential curve. It's like, well, there's two cases, there's 4 cases, there's 8 cases. That's not scary, but if you know what you're looking at
Yes, yes.
pattern wise, that's terrifying. Have you ever seen data deliberately misused? Is there sort of a worst possible example?
Well, this is various race statistics. I always know that one. IQ is a classic. Remember, some of the statistics used to show black Americans had a lower IQ than white Americans, and someone would say, "Oh, well, therefore you should just always pick a white
Yep.
person." And you say to them, "No, no, 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 no. That's not how it works. You're better off asking them what their education level is, rather than the color of their skin, if you want to measure their intelligence."
Yep.
It's just people draw the wrong conclusions from data. Race statistics is a classic example. Crime statistics. There's lots of statistics which people draw a very simple conclusion from. The conclusion is more complex. Back to ecological fallacy, drawing the wrong conclusion because the analysis is actually not, again, you haven't used the correct variable. If you've used education level, the classic one was the Robinson's article in the 50s about education levels by state. What was it? I can't remember, but they drew the wrong conclusion. The variable which was important was the amount of money a state spent on education, not the proportion of black people in the state. It was just the wrong conclusion based on ecological fallacy. That's the one I always tend to find, is that you really have to look at your assumptions in the data. And I do think that people, particularly nowadays, because it's so easy to do a regression, people show regressions, or people who show correlation figures when they really should be doing a regression to get the distribution on the variable in the regression. There's lots of different things where people have used the wrong statistic. If I look at a newspaper graph, I always look at the scales. That's always very interesting. Or why has someone used the change value rather than the raw value? You always have to ask, what's the more important variable for me to look at? And I know when I do graphs, I'm trying to demonstrate something. You want to make sure that the data is interesting. I don't often use. I was doing some work on group voting tickets. There's a blog post that we're working on, and I'm looking at why group voting tickets were so bad. And I worked out, if you measure the first preference vote of the candidate who was elected against the candidate who they passed to defeat, in a single member electorate, it never gets above a 2-to-1 ratio. But in some of the Senate seats where this happened, that ratio was getting to 50-to-1 because of the way the ticket preferences were controlled. And when I came to graph that, it looked terrible because you had these points up here and a bunch of dots along the line. I did it with a log graph and it looked beautiful. It's not very often I get to use a log graph in social statistics, but as an example. I think scale, whether you're using value or change in value, whether you're using raw numbers or percentages, they're always things I look at. Every so often, I tend to use percentages a lot because of the field I work in. Every so often, someone comes at me with a number, and I think that was interesting. So I was looking at the Aston by-election in terms of percentages and change. Someone sent me a note and talked about the number of people who voted for parties at the last election as against voted for them at the by-election. There was a lower turnout, but that was actually very revealing, more revealing percentages in some sense. So sometimes just looking at the data in a different way gives you something. But I think when I see something in a newspaper, I always look at that. When I read papers, academic papers or journal articles, I always try to look at the graph and understand the graph. Most people just skip the graph. I look at the graph and think, what's this saying? Why have you drawn that straight line there? Why have you dropped these values? Why have you used that scale? There's things like that which I think are interesting to look at. The other thing I'd always say to students who, because I'm from the days when using computer statistical packages wasn't very common, and in those days, if you did a regression, you would often extract the outliers, look at the outliers, because the outliers haven't fitted your straight lines. Have a look. Is there something in the outliers that tells you there's a variable you should include? The other thing I tend to find is just tell someone to graph the data. Just look at the data. Don't just rely on the statistic coming back. Now, when you're doing multi-level regression, of course, that gets complex. But on particularly single-level regressions, just look at the graph. Sometimes, and I suppose a lot of people just don't do that nowadays. They just feed it through a statistical model.
And produce the default graph, which has,
Yeah. So I mean, I'd always
and things like that.
Encourage people to do that, and it's interesting. It's enjoyable. Occasionally, someone does something in a newspaper. Usually, it's a lobby group in terms of my area, politics. Someone's lobbying for something, and they do some strange regression on numbers versus something else. And I'm thinking, oh, what's that? That's the main thing I notice.
Yep. It's not all that difficult to manipulate your graphs to convey the message that you want to convey rather than necessarily an accurate impression of the data. That brings us to our final question. This has been fascinating, honestly. I could do this all day. What excites you about data?
Just being able to figure out. I mean, in terms of what I do, which is like model the election. Like it's that data is pretty dull. I mean, to sit there and work out. All right, there's a new polling place in this suburb. I'm going to transfer 25% of the history from this polling place to this other polling place as my history background. So preparing that data is dull, very dishwater talk. It's very dull. You're doing that sort of preparation, but in the end, you're doing that sort of preparation, so it builds into your data model, and then come election night when the figures arrive, it all comes up, and there's the money shot of who's won the election. So that fascinates me. You're taking data which you can't see anything in, and you're turning it into something where you can see something.
That's awesome. Thank you so much. This has been amazing. It's going to be fascinating to hear the feedback we get afterwards and the interaction, because this is I'm clearly gonna have to listen to this several times in order to wrap my head around it all. It's been so good.
I will say that I did do a lecture to a Linux conference the other year, which if you can, I think I sent you the link if you can let people know that that's there if they want to know a bit more detail what I do. But I hope this.
Yes.
I hope there's people who follow this blog just see that I don't just turn up and talk on the night. There's a vast amount of background that goes on, and to know, I mean, some of the stuff like knowing history of stuff is just like that's my background experience. I mean, I did this project a number of years, built a database of every New South Wales election back to 1856 as a history project. You had to actually find data sources in the newspaper.
Wow.
So that sort of stuff's interesting, getting data and putting it into a useful form where you can find it and it's all indexed back to where the data came from. So some of that's just interesting. You're making stuff useful. And having done this area for years, finding somebody who's pulled data into a useful format which you can make use of is just extraordinarily useful. So I hope people understand that I'm not just turning up on election night and talking. There's a fair bit of work goes on in the background to do all this, and people sit there and say, you're wrong, or you're right, or it's not. It's like there's something going on in the background which causes me to say what I'm doing. If an assumption like at the New South Wales election that the pre-polls and postings would follow a past trend, in fact, doesn't happen, then I haven't made a wrong call because I ignored something. I made an incorrect call because the data was different than it's usually been. So it's always you always learn, and in the end, if the trend data changes over time, you have to try and take it into account. But if the trend data changes over time erratically, all you can do is allow greater variability in your predictions, so you allow more data to come in before making your decision. In the end, I always say to people, when do you know the results of an election? And I say by 7:30, I will either be able to call the election or say we'll have to wait for more data. So in other words, if in doubt, you have to wait for more data. And if you've got a really close election, well, they'll be counting for 2 weeks.
Amazing. There's a lot that goes into it, isn't there?
Well, it's been a pleasure to talk. It's nice to talk in this abstract manner about what I do rather than the politics of it. In fact, behind the politics there's a whole bunch of numbers, and they're interesting for anyone who's interested in data.
That's right. It's fascinating to start rummaging through and learn more about the way it all works. Thank you so much. It's been fabulous.
Thank you. It's been a pleasure to talk.
Thanks for listening to Make Me Data Literate. You can support the work of the Australian Data Science Education Institute at givenow.com.au/ADSEI. Tune in next time for more conversations with amazing data experts.